Now let us go to the actual subject, system approach. How do we do? Once we are thorough in this, how do we approach the systems? The first is problem identification. So there are only 2 points, 3 points you can remember. One is problem identification. Once you identify the problem, immediately you have to see the opportunities. How do we resolve these issues? Then you will work out the solutions, so many solutions, then you will evaluate, then you will go for a final decision. So let us see one by one. Problem identification. First, you have to involve stakeholders. So what happens when we involve the stakeholders at this stage itself? For example, if you are installing ILS Cat 3, so you have several conditions for the mains and the backup power supply changeover timing. So it's better to involve the electrical engineers right from the beginning, so that their expertise will be, and their difficulty, their concern also we will able to list during this stage itself. So it's like stakeholder engagement. It helps us to gather diverse perspectives and understand the different people need, concern and expectations. Then context analysis. We need to see in context in which the system will operate. Suppose you are introducing Cat 3 ILS. If that airport is having foggy condition or heavy rain condition, the nature, now you are not able to predict the nature, but still more or less we know which airport is the topography is bound to heavy rain, heavy wind. All these things we will be able to see. Accordingly, we should see certain analysis and what is the traffic pattern, what is the social and economical issues are there in the particular airport. It is a joint venture or it is our airport. There are so many things are there, and technological factor also you have to see. And system boundaries. Here you should be very clear. Once you define the scope, 50% of the unexpected problems won't come before commissioning. So we need to decide which are the factors to be included, which are the factors to be excluded. Then root cause analysis. So you have certain need. That's why you are going for a new system or new project. So you need to understand what the problem in front of you, how you are going to provide a solution through your new system or project. So we need to do the root cause analysis. There are various methods are there. Fishbone diagram is one of the frequently used diagram. So this we will not discuss in detail because of that. This is only introductory nature of the discussion. So root cause analysis is one part of the problem identification. Then you have to gather the requirements. So the requirements definition is a very important part of the document. So once you make a requirement, you should also visualize how I am going to verify this. So that is the basic system engineering philosophy. So once you make a requirement, say suppose you are writing my battery should give 12 volt, then you should also know how you are going to verify that. And if you are saying my battery should give 12 volt under this much load, then also you should know how you are going to verify this during the test. So these things, once you have done the problem identification, that is one of the major step is done. So next is opportunity identification. What we will do in this opportunity identification? First is market analysis. You made some solution. Say for example, you are going to bring so-and-so baggage systems, so-and-so conveyor belt system, so-and-so security system. We need to analyze the market. What are the potential opportunities for new systems that will give the improvements you are looking for? Otherwise, there is not going to give an opportunity for you to implement those solutions. The next is technology assessment. This is very important. When you are evaluating emerging technologies, we need to be very careful. Sometimes these technologies may not continue for a long time, but we used to have our service lifetime already predetermined. So we need to see these technologies whether we can bring the new capabilities and exist and improve the existing capabilities in a longer run. You have to see at the same time whether this technology is definitely bringing advantage to the system that we already have. So we need to do one SWOT analysis at this stage. Generally we don't do, but it is very easy to do and it is we must do. So what do you want, Mr. Avilas? So what I suggest, I would suggest you keep your questions in your, you keep your question, we will discuss at once because it is a very short program. So we will come back to you at the end of the session. That time we can discuss. You can keep a note of whoever is having question. You can just note down the title of the slide and point that we are discussing. Okay. So for example, I tell you this is SWOT analysis. Some example I wanted to tell. How you do SWOT analysis? You will identify internal and external factors, how it can influence in your success of the system. See, all of us are belong to different domains. So if I give an example of ATM domain or CNS domain, it may not be good. Means everyone may not be able to understand. But all of us as a passenger, we know definitely about airport passenger and baggage handling system. So I wanted to give some example with this airport baggage handling system. I told you have to do the SWOT analysis with the internal design. So you have to see what is strength, weakness, opportunity, and threat. Suppose system design, that is part of the system that you are bringing. So the strength, you can say advanced automation ensures efficiency. When it comes to it's become a strength, the same time it will bring a weakness that it will may increase your setup and maintenance cost. But at the same time, what is the opportunities to bring the new automation? You can integrate with the AI for predictive maintenance. So there is no need of too much of maintenance costs. That if the system is designed in such a way, on its own it will do a predictive maintenance of the system, so that you will be take corrective maintenance at the proper time. What are the threats? System failure during peak time, that will be there. So how do we assess this? These are all internal to the system. It's a technology. This is also internal to the system. Real-time tracking with the RFID tags. That is one strength. What is a weakness? It is dependence on the proprietary technology. Means something you have to take certain people, some type of technology. You may have to pay royalty, so many subscription fees, and all those things will be there. And also you are dependent on somebody. You are not independent. Then opportunity, you can introduce Internet of Things for enhanced baggage tracking. This is one example. You can introduce new technologies on your in-house developed technologies also you can introduce, so that this part of the technology part will be taken care by internally. What are the threats? Cyber security vulnerabilities. So whenever nowadays we talk about the new technology, definitely cyber security also you will have to see. Now similarly you will see the external factors. External factors, as I told, it is not within the system. It comes from the outside. For example, strength. Compliance with IATA standards ensures reliability. So you want to follow those standards. But if that compliance standards are keep on changing, and if it is very stringent, then you will be finding a difficulty in upgrading those compliance standards. So what are the opportunities when you comply to those standards? You are adapting your system to new international standards. Threats, changes in global regulatory requirements, like I told. IATA may change some standards. Say, for example, you may have some security system of particular X-ray package. Suddenly, some global standard is changing. Then you may have to change all the X-ray machines in your entire India. It's a huge cost it will come. That's a threat. So what is the market trend you have to see? Demand for seamless travel experience, that will be a strength. At the same time, high competition from emerging technologies. Opportunities, partnership with the airlines for system upgrades. Threat is competitor airports adopting superior system. Naturally, people try to compare with your airport with whatever the airport they see. If they come to some big, beautiful airport, definitely they are going to compare with that to our airport. Similarly, all these things, when a competitor is having different type of baggage handling system, when the passengers find a benefit, they expect the same thing at our airport also. So once we see all these things, the problem statement and the opportunity identified, then we will go for the idea generation. So idea generation, what you have to do? You have to do brainstorming first. So brainstorming session with the stakeholders and team members to generate wide range of potential solutions. I told you earlier itself, this brainstorm also will be effective only when if you are having system thinking, system approach. Otherwise, you will not even know who are the stakeholders to be involved in the brainstorming session. Otherwise, what will happen? Your brainstorming will not be effective. You may be interacting with a few stakeholders, and your entire concentration will be on the particular dimensions of the system, not on the 360-degree dimension of the system. Then benchmarking. You are brainstorming. At the same time, you can see the evidently visible best practices around you. Maybe some best practices are there within the Airport Authority of India. Maybe some best practices are there from our competitors. So we can see those best practices so that we can benchmark for the potential improvements. The next is structural analysis. This is what I told. System engineering and system thinking brings this kind of analysis. Structural analysis is what systematically will explore all the possible combination of solution elements. So, for example, you will define the problem first, then identify the key functions of the system that you are thinking and what kind of solution you can bring, solution elements you can bring. Then explore different combination of those solutions, then evaluate different combinations, then finalize optimal combination. Document the evaluation criteria. Again, this I want to explain little bit more with the example of our airport baggage handling system. For example, define the problem. The problem statement is this: design an efficient, reliable and scalable baggage handling system for a large international airport. What for we have to do this? The system should minimize delays, handle peak loads, and integrate with the other airport systems. So this is our problem. This is the very first step in a structural analysis. So next what we will do, we need to identify what are the key functions right from the passengers dropping the luggage. How do we handle the check-in process? Then how do we transport these goods to particular place? Then how do we sort these baggages? Then how do we storage temporarily? And how do we connect all these information with the other systems in the airport? Then ultimately we deliver. The same thing you can think in the aircraft offloading also. When we arrive, when an aircraft arrives, how do we take the baggage from the aircraft? How do we transport? How do we sort? And how do we deliver to the passengers in the conveyor belt? So this is the entire cycle you have to go through, the entire system. It's not that only we will think about a conveyor belt operation. No, the entire thing, if you think that conveyor belt operation and the system synchronization can be scientifically can be made. Now let us see, explore the same example. Now you identify certain functions. Then we have to identify so many solution elements. It can be so many solution elements. Just I am giving only one example. For example, baggage checking, manual counters. The second solution can be intelligent system with a kiosk, self baggage drop. That is also available in many airports. Like this, you can identify different solutions for each function. Transportation. You make a long conveyor belt or some AI-based automatic delivery vehicles. Like this, you can list based on your financial condition and your technology uh, appetites. You can make many solution elements you can work out. Similarly, sorting. It can be barcode scanning system or AI-based sorting system. Storage, automated shelving system or manual shelving system. Integration, how you will integrate these processing with a centralized management software. And how do we deliver? Say conveyor belt to baggage claim. Then next element. So what will happen once you do scientifically? For each function, there will be so many solution element you will list. Maybe some 3-4 element. Once this is available, you have to compare this as a combination. You can make several combinations. Say for example, combination 1 I listed here. Self-service kiosk for the check-in. Means you listed several elements. Now you are making certain combination out of that. Conveyor belt for transportation, RFID for storage, integration, cloud-based integration system you will make. Delivery, you will make conveyor belt to baggage claim, how you will delivery. So once you make like this several combination, next what you will do, you will have to evaluate this combination. Let me quickly recollect, because since we are going in a non-interactive manner, First, we are identifying problem definition we are doing. Then we are seeing the opportunities. Then we are working out the identifying the function. Then each function we are identifying a solution element. Then within that solution element, you are making different combination. Then next step is analyzing those combination. So how do we analyze a combination? We should fix certain criteria. For example, cost. What is the initial investment and operational cost? Efficiency. How much time required to process and deliver baggage? If you introduce the system for this much cost, what kind of efficiency we should get? And what is the scalability? In future, we may have to expand the system for the future growth. Then what is the provision of scalability? You put a lot of initial investment, but if it is not scalable, then also the system is of no use. Similarly, reliability. How much it will be uptime? What is the fault tolerance? Then environmental impact. What are the, how do we use the energy? How much energy is used? Suppose you are using battery operated vehicle. How much energy you are using? Similarly, that battery becomes waste. You have to in this. One is multi-criteria decision analysis. So whatever we have seen the criteria, no, we have made a cost, efficiency, reliability, scalability, all those things you have to define first. To achieve this criteria, what are all the solutions we have to do? Then we will rate each solution across the criteria. We will score some weightage and give some score. Then we will rank all the alternate solution, and then we deliberate along with the stakeholders. Then we will come to a conclusion on what are the solutions we have to make. Next is cost-based benefit analysis. So we will identify what are the costs are involved in this system, what are the benefits we will get once we implement these costs. So here how it will start? It will start with a cost, list of costs and list of benefit. Then we will assign the values to the cost and benefits. Again, we will calculate the net benefit. Then we will rank the solution. Further, we will interpret and recommend a particular solution. So how do we selection and justification? Whatever we do, we need to interact with the stakeholder, what evaluation criteria we followed, and how we arrived at this particular solution. And these should be documented, and all these things should be reviewed with a stakeholder. See, suppose this is a big process I have told. You may think that, suppose take for example, you are installing ASMG system or any other runway lighting system. Maybe you might have outsourced this entire SITC project to somebody, but still, who will prepare the site? Site will be prepared by you only. Site will not be prepared by the SITC vendor. While preparing the site, you may need some small space in the airport to keep some of the sensor or some of the server. That is also need to be seen in the beginning itself. Otherwise, practically, you will find a difficulty in the end of the stage. Oh, we have not found a space for keeping this equipment. We have not made provision for energizing this equipment. So this will also delay the whole project, that may create a big loss for our organization. So irrespective of any of the thing, as I told earlier, we need not have very big detailed certification of system engineering or project management, but we need to have the entire steps. Say for example, you are a AM or a joint GM or a GM. If you know the steps, if you are able to do some little bit homework before the each stage of the project, definitely you will be doing better than what you are doing today, and overall definitely will save time as well as money. Now we will see, we discussed so many things. We have discussed very basic things as we are introducing a system engineering. Now we need to know where and how it is applied in the practical real world example. Then only we will get more interest to learn this system approach and system engineering and apply in our field. For example, the first thing I will start with the airport security system.